Hello, good morning, good afternoon.
Hey, good morning. Hey, David. We're in Atlanta.
I am. I'm in Atlanta right now. Yeah. Just got in and it's freezing. It's so like people down here are not used to this kind of cold. The 20-degree lows are getting down into the teens Fahrenheit, highs in like 40 degrees Fahrenheit. So yeah.
Pretty cool.
How's everybody else doing?
Get some rest from the long weekend. Be good. Recharge.
Yeah, so for me, I'm trying like to catching up. I came back late last week, back from holidays and trying to catch up and see like the status of all the different things. Still like catching up with documents, emails. Now like we are migrating from Slack to Google Chat, so I don't know what chat to check every day. It's amazing.
The way I feel about Teams and Slack, and then Zulip and like the 15 different chat clients that we use at
Yeah.
this point.
Yeah, I get the Tulip digests on the email. That's what I try to check because if not, it's like it's too complicated.
15 different ways people can interrupt your day and at a moment's notice.
Exactly. Yeah. I will need to create a schedule for the week. Like every day I check just one platform.
Yeah. It's like, oh, let me stop to see if anybody's interrupted me yet.
Yeah.
Everyone, now it's 9:05 in Pacific time zone. Let's get started. I'm going to share my screen. Welcome. This is the Run WASI and Containerd WAS and Shim's community call. And this meeting happens every the other Tuesday at the 9 a.m. PDT. The first thing I want to say is congratulations. We got two new active maintainers, James and Jorge. They've been very actively participating in the peer reviews and feature implementations in Run WASI. Jorge has done a ton of work to improve our infrastructures and CI/CD pipelines, as well as code refactoring in the core crate. And James has been driving the OCI artifact work in Run WASI for quite a long time now. So congratulations. This is the CNCF Containerd Run WASI meeting, so we have to abide by the CNCF code of conduct. The meeting has been started recording automatically. And please encourage all of you to use the raised hands feature if you have any questions or anything you want to discuss. So let's take a look at the agenda today. I will be your host, Joe, and we currently don't have a note taker. I will ask one of you to be a note taker if anyone is interested.
I'll do it.
Good. Thanks, David. Great. Attendees, please add your name here in the attendance list. You may find this doc in the Slack channel. It's pinned on top of the channel itself. All right. I don't think we have new members or attendees. So let's move on to open discussions. I put two open discussion items on here. The first one is a follow-up on the WASM pod terminating stack in Kubernetes issue. So basically the TLDR for this issue is people have successfully created pods in Runwasi or Community WASM shims, but they have a hard time to terminate the pods because they are stuck at a terminating status for a long time, and there's no progress going forward. So the status update I want to give is I have done some testing on the newest, the main branch of Runwasi, and I added the delete the pods in the CI/CD pipelines. I don't see any issues particularly. And I think David has encountered issue in ARM64 macOS for Docker Desktop, and James at each appear to fix the issue in the TTRPC repo. So that's the status update. Does anyone have any questions on this issue? All right, not. Oh, hey, David, please.
Sorry, I was very slow to raise my hand. I'm wondering if anything has to do, like, I'm wondering if there's environmental factors that are coming into play here. Because I don't think we've been able to, have we been able to induce this in our integration environment? Were you able to witness this test failing at some point on integration tests?
No.
Okay. All right. That kind of concerns me. Because if we aren't able to replicate it, we can't be super sure that we have fixed it. I would like to learn more. I think, closing the issue perhaps and having somebody reopen it, as long as we can get some more information. In fact, if we could find somebody that's running into this issue, perhaps, like, I know we ran into one person that was using Runwasi, and they were using it with AKS originally, and not necessarily Runwasi, actually the Spin Shim, which obviously indirectly is using code from Runwasi. And they were using this, and they saw the failure in AKS where they're in the Azure Kubernetes service where they're using it, and then they shifted from using the installed version that comes with Azure Kubernetes service, which is a little bit behind the released versions, and then they use the KWASM to install newest bits, and they saw this problem go away. So to me, that signaled that there was the bug had been resolved. However, without being able to very clearly point in our integration pipelines, it still worries me.
I guess the major concern you have is we didn't exactly figure out what's going on in the terminating status, like, or what kind of changes went into Runwasi that fix that issue.
Maybe one possible line to get more information about this is to ask this user if he or she can reproduce the same environment that that is using, but without any other service. So just try to isolate the issue, try to reproduce the same. I don't know if it's use a managed service, for example, just try to create a Kubernetes cluster from scratch, drop the smallest installation that you can to run Runwasi and Wasm Edge, and try it again.
Brian?
Yeah, so kind of just breaking down where the problem could lie. Like if we're getting a termination signal, once we terminate the pod, we're expected to do two things. Expected to send a container exit event, and we're also expected to release the container wait API, because CRI is watching the /wait endpoint on the shim to know when the container is exited. So either we're getting stuck while we're trying to send the termination signal and stuff's just not happening, or we're not releasing the wait because something else is either stuck or it just hasn't notified that condition variable or whatever we're using these days to release. So just kind of thinking about some of the technical aspects of what's going on there, where we can look. I posted a comment on the issue, but that's kind of where I would start is what are we failing to do in the shim? Where are the blockages that could potentially happen? Like deadlocks and that kind of stuff. And it'd be cool. Maybe we can throw together a little TTRPC client that can manually call into that specific shim to perform those operations, and see what happens.
David?
I think that's a really awesome pathway. One, I find it difficult to debug at that level, like containerd and communication between TTRPC and containerd. So debugging the shim, setting up a debugger to see all the traffic that's going through, or at least seeing those signals. It would, I. How do you go? Like, I'm curious how you go about it, Brian, because you're a wizard, and I've learned so much from debugging with you. But more so, can we make it easier for people that maybe don't have, those deep skills? Like, would it be useful to have, tracing? Would it be useful to have more? I don't know, the ability to have more verbose logs, like, hey, wait, entry point called, and never seeing like wait or never seeing wait signal returned. We know sadness has happened. I don't know what folks think about that.
Yeah, so there is support for OTel in containerd, so we can wire up that to at least handle the gRPC endpoints. There is no TTRPC level OTel stuff at the moment, so we won't have that visibility, but we would at least have the gRPC side, so at least the client to containerd and those things we're expecting to see in containerd. Other than that, yeah, you're gonna have to turn on like debug logging and stuff to get more information. That said, there's like we've been discussing getting TTRPC support for OTel, or the other way around, OTel support for TTRPC. There's just a lot of headache involved in making that happen in terms of like dependencies, and because OTel is what's this recorded, so we'll just say it's fun to deal with, particularly on the Go side. And on top of that, the overhead, memory overhead and all that adding new libraries adds in something that is opened for like one per pod. It really blows things up. But I think on the Rust side, having OTel is going to be much easier than on the on a Go shim, because it pulls in HTTP2 and stuff like that. And it's like just a massive memory increase. So I don't know if we could do it on like a Go shim, but on a Rust shim, it's much simpler anyway. So that's something we can definitely look at. And actually, there was even just movement on that TTRPC OTel stuff today. So Maybe in 2.0, we'll Container 2.0, we'll have that.
I have one comment and one question to what Brian just said. So I'll go with the question first. Brian, when you say there is no support for OTel in TTRPC, I immediately thought there is an issue in RunWazi to upgrade the task API from version 2 to version 3. And in part of that, version 3 introduces the new gRPC APIs alongside with the TTRPC APIs we're using right now. Do you think that will help to add OTel support?
I mean, definitely, yeah. So if we're going to use gRPC, the main thing to look at is what overhead is that going to add to our shim? Because we will need to keep the memory usage to a minimum, which is kind of why TTRPC was created. Using it on like a sandbox or like with like the Wasm Time D thing, that's great because we have one gRPC service, and the overhead of that is amortized over multiple pods instead of the same overhead on every single pod. So just kind of measuring that to see if it actually will work out for us. I don't know what that's like on the Rust side. On the Go side, the gRPC library is massive. Yeah, kind of a headache. But
got it. And a comment to what Brian said about the terminating status and what could be the causes of it, or what's the workflow from or the API workflow from the continue DD to the shim. I'd like to pull up a architecture image, if you allow me. Give me one step. There is a Containerd runtime API stack. It's this one. So at the end of this spec, I think there is a very nice flow diagram that describes the API workflow from Containerd to the shim and back to Containerd. And Brian, would you like to elaborate what API from Containerd sent to the shim that starts to terminate the pods or the containers?
Yeah, I'd have to look at specifically what Cry's doing again. It's been a while, but so typically what we're going to have is a kill request, which is going to have a signal in it. Should be that it works the same way Docker does, where it sends a stop signal if it's supported, or sigterm, and then after a period of time, send sigkill. When that happens, because it's just a signal, it's just like basically we're sending sigterm to the process, just over an API, over an RPC call. So we're not expecting anything back on that other than the response to say, okay, that was performed. Sending a signal is not gonna say this exited. It's just like, okay, yeah, we performed that operation for you. What we're expecting to see after that is a container exit event, or for CRI specifically, we're looking for the container wait task, or the task service wait endpoint to exit. So it's going to send a status information back to CRI. So for every single container that CRI manages, it has a call to the /wait API on every single shim for every single container.
Right.
And yeah, so once that has gone away, either because the shim exited or because we sent a response saying the task exited, with the exit code and the time and all that kind of stuff, that's when it starts like, okay, now we need to call task delete and clean up after it.
David, you have your hands raised.
Thank you, sir. I was finishing up the last note there. So I think what was actually causing this is the TTRPC connection getting disconnected before sending back like wait is finished. So I think there was a disconnection between the shim and container D that the wait being finished was never actually communicated.
Yeah, I think in that case, and it could be I mean, if it's not this, it could be a bug in the CRI side. But what should happen is once that disconnects, container D assumes that shim is gone. And it should be doing things to clean that up. Including it's still going to try and call attacks delete and end up failing if it's not connected. But that the disconnect shouldn't be a problem. That said, CRI might have a bug. That's potentially possible. And relatively easy to check too, because we could like just sid kill the shim and see what happens. But actually a good thing to put in automated tests to make sure it works on our end. Send a sid kill to that thing.
Awesome.
Do we have anything? I'm sorry. Do we have anything additional to discuss here?
No, I think we can move on. David, you just add this agenda item, I assume. I can talk about the one at last because that's a build failure.
Okay, sure. Can you open that link for Slack?
Yes.
All right.
I'm just sharing my browser right now,
So,
so give me 1 second.
Yeah, it's so unfortunate. I really wish it would just deep link right into the app. That would be nice. Anyway, the gist of it is somebody had posted a comparison between Run and Runwazi for executing WASM workloads. And I believe it was nearly an order of magnitude slower. Or at least the way that they were, checking it out. So
Just make it bigger.
I don't think we spent much time in, and I need to look into the test a little bit more. Let me see if I can.
Yeah, so I'm not sure what CRun is doing. I know I've seen it be slow on Runwazi. but like every bit of that is compile time. So like with the precompiled module stuff, it goes quite fast. So I don't know what all crun could possibly be doing other than maybe starting compilation early, like before the start is called.
Right. And that seems like a totally reasonable approach. Like, we aren't even gonna add to your code until you've like fully like jitted this or AOT'd this for your platform.
That's it. I wouldn't expect an order of magnitude for that because like those calls are going to happen pretty quick.
Yeah. But this kind of draws back to the, hey, is this a debug? Is this like what's going on? Like, how do we determine what's going on? And we don't really have a lot of really good tools at this point, besides just hooking up a debugger to it and step by stepping through.
And I'm also confused about, or not confused, not clear about what they're measuring. Is it when they start the image, start measuring that, and at the end of the sprint, stop measuring?
Well, and these are all good questions, and something we should be curious about so that we can improve, right?
Indeed, and it could be something up with standard IO pipes for that matter. Like something's getting wired up too late or something like that, and it's just not able to write to that pipe early enough.
Oh, they provided the scripts. Never mind.
Yeah.
Yep.
But it's just not something the project is really focused on. Like, we haven't really, deeply focused on performance yet. And it was more about what should the developer experience feel like. And it's a good time to do it, I think, or it's a good time to start evaluating where the differences are.
I think there is a related issue. I just want to link here. It's in container device and shims, and Kate was experimenting something to improve the shim performance for the spin shim. So they were noticing some performance issues in the spin shim that could be correlated to the RunYZ performance issue here. So to the notes. What action items do you want to take from there?
I think almost all the roads point back to debugging and observability and doing all doing all the dirty work.
Yeah. I think we should be able to do some interesting stuff like add our own metrics. Well, I don't know if that'll work. We could see if it would work, but add custom metrics to the task metrics endpoint. I don't know if that'll take custom stuff, but let me see. Which you can like go and ask Containerd for the metrics once you start exporting that out and see stuff like, oh, how long did this take to compile? Where did this other stuff happen? And for that matter, going back to the hotel stuff and tracing and be greatly helpful. So unfortunately, we don't exactly know.
Do we have any more open questions or anything you want to discuss on this issue? The Wasmer shim has also a significant slower compile time in the shim than standalone. Hey Sven, would you like to elaborate on this? When you say significant slower, do you have like an estimate of how much slower it is?
Hi, so connection isn't the best. Yes, so what I noticed is when we build the Wasmer shim, when you start up the container, it can take, depending on the WASM file, up to half a minute to just be available. And most of the time, it's just compiling the WASM. So it's a WAS6 container, and it's maybe just related to this issue that somehow the things are slower in the shim for I don't know what reason. So just my 2 cents.
Thanks. Going to share back my talk. All right. Last, let's talk about this thing. So in container device and shim triple, I have recently encountered a build failure. This happens in my local as well as in the CI. So it's a bit universal. And this is for any shims in the container device and shims, for slide, for spin, for lunatic. Although this is staying in the lunatic, but if you just disable that shim, you will see the same issue for other shims as well. And I'm not quite sure what happened. There's no change in the environment. There's no change in the Rust version or the runwise core rate. But when we compile to the muscle library, let's see. Let me just copy this to you all. I will see something like this. Relocation against something cannot be used when making a PIE object. Recompile with -f PIE. So is it saying that the muscle library that in the cross image is not a PIE object? So we have to recompile the muscle library with this -f PIE? Or is it something I'm missing? and all of the arrows below are basically the same.
Yeah, it looks like some linked object is not compiled with PIE. Hmm.
I wonder, could it be something that cross a new version of cross where the main branch of cross suddenly breaks something in the image? And by the way, this is the x86 Linux muscle image. So my initial thought on how to debug this is go into the image and recompile muscle library with the -f PIE and see if that works. David?
Hey Joe, did you see the Rust issue? So there's a couple Rust issues that come up associated to this. Is that one of them, Brian? I mean,
Would you like to paste a link? Oh, yeah, I saw it. Trying to upgrade to Rust. 159, that's a pretty old version.
Yeah, and here they said if they use cross, they don't have an issue. At least that's, I think, what I read. But
So this is similar. For relocation mod.
I just gotta say, isn't it so fun to use native libraries?
It's nice until you hit this kind of stuff.
It is. It's great. It's like so powerful, and then all of a sudden, oh, we're back here.
Like when you're in Go, it's like, oh god, a native library, no. But when you're in Rust, it's like, oh, thank God, I can use these native libraries, and then you get the stuff.
Yeah, 100%. I like the idea that like gonna just we just don't do this. Like you're gonna use a whole new tool chain like CGO. Be done.
Yeah, I think we haven't pinned the Rust version CI device and shims, which isn't a good progress. All right, gentlemen, I'm not going to take more of your time. I can try to debug this myself.
I'm sorry we weren't more help.
Oh, that's okay. It's a difficult thing.
Joe, I'll help you Google any day.
Stack Overflow master.
Hey, and then maybe together we can sort it out. Yeah, I haven't run into that one yet, but yeah, happy to help or at least be a sounding board when you're very frustrated.
Yeah, I think what I'm going to try to do first, it seems like some Rust version messed this up, so I'm going to pin Rust version to some version that worked before. And if not, I'm going to pin the cross version. If none of them helped, I guess I have to build the master library myself.
Yeah, we're gonna have to make it work with the new stuff if it does fix it anyway, but at least it'll make CI not flake out.
Cool. Thank you so much. I'll see you in 2 weeks.
Cool. See ya.
Thank you so much for leading the meeting, Joe.